All right, let's dive right into this explainer. Now, a Node.js SDK is not just a cleaner wrapper around fetch. As we're going to explore today, once multiple projects depend on a simple API integration, it absolutely becomes the ultimate reliability layer for how your entire team handles API failures.
Section 1. The API integration trap. We're going to start with a really familiar, almost innocent scenario. A single developer writing a quick integration just because one project needs to call an external service. They write a quick fetch request, it submits the parameters, pulls for the result, parses the response, handles a few basic errors, and then returns the output. And hey, the code works, the feature ships, the team pats themselves on the back, and they just move on. Or so they think. But then, the integration spreads like wildfire. Suddenly another app needs the exact same API. A background worker copies the polling logic. A QA script adds a completely different timeout. A batch job decides to skip balance checks entirely. One service retries errors that absolutely shouldn't be retried, while another just treats every single failure as a generic exception. And oh, a third project upgrades Node.js, but the old wrapper assumes a completely different runtime. Eventually, nobody knows which implementation is actually the reliable one.
And that rising chaos? That is exactly when an SDK stops being a simple developer convenience. Section 2. The operations layer shift.
A Node.js SDK for an external API is not just a nicer way to call endpoints. In a production environment, it dictates exactly how your organization handles submission logic, error classification, retries, and method naming. Think of it as a protective shield that guards your internal systems from external unpredictability.
So the crucial point isn't only can the team call the API? Honestly, that's just the bare minimum. The better question, the one we really need to be asking, is can the team actually operate this API dependency predictably across all their projects?
Section 3. Centralizing core SDK logic. Let's get into a practical checklist to gain back control, starting right at your core logic.
Step 1. Define the SDK's operational role. Ask yourself, is this for one internal script, multiple services, a QA pipeline, or maybe public distribution? The wider the use, the stronger the reliability requirements absolutely must be. Step 2. Centralize your submit, poll, and parse logic. Stop repeating raw fetch calls across projects so everyone uses the exact same API behavior. And Step 3. Use custom error classes. Seriously, stop treating every failure as a generic exception.
Separate your submit errors, solve errors, timeout errors, and bounce errors. Looking at the Capture AI troubleshooting data here, you can see how clear error types give teams crystal clear next steps. For instance, a timeout error means you might need to check your network or increase the wait limit. A submit error due to an invalid key or a zero balance, that means you need to fix your account. And a type error complaining that fetch is not a function tells you instantly that you're running on an outdated Node.js version. These custom errors dictate whether you retry, alert, fail fast, or just stop the workflow entirely.
Moving to Section 4, ensuring operational reliability. Once the logic is centralized, we have to configure the SDK for the harsh, unpredictable realities of production.
Step 4 of our overall checklist, make timeout and polling configurable. Different workflows need very different wait limits. Like a batch job might tolerate a long timeout, right? But a user-facing process needs a snappy response. Defaults are super useful, but production users really need control. Step 5. Define your retry strategy explicitly. Only retry known transient conditions and use smart backoffs with strict limits. Step 6. Proactively include balance checks. Balance visibility is a huge part of reliability. A missing balance check can turn into a total production interruption before a high-volume job even starts.
Listen, I want to emphasize this rule heavily. Fatal errors like wrong keys, IP restrictions, or a zero balance are hard stop conditions. Careless retries on fatal errors will just increase your costs, create unnecessary load on the system, and completely hide the real problem. Just do not retry them. Section 5. Enhancing developer experience. For the final part of our checklist, we need to focus on how this SDK fits into the broader engineering ecosystem. Step 7. Plan your package and runtime compatibility. Node.js SDKs depend on runtime assumptions, like explicitly requiring modern Node.js versions for native fetch. Step 8. Add type support. For internal use, JSDC might be enough, but for larger teams, TypeScript definitions dramatically reduce misuse and really improve the developer experience. Step 9. Add observability hooks.
You want to expose operational metrics like task duration, timeout status, and error codes. Finally, step 10, assign ownership and versioning. Who maintains it? Who manages breaking changes? Who writes the release notes or helps downstream projects upgrade safely? Without a clear owner, the SDK just becomes orphaned infrastructure.
Section 6. Common SDK mistakes. To wrap things up, let's run through a rapid-fire list of common pitfalls you absolutely want to avoid.
Decentralized logic, generic errors, hard-coded values, retrying fatal errors, skipping balance checks, ignoring node runtime constraints, and publishing without documentation or an owner? Look, if you catch your team letting every single project write its own API logic or hard-coding values, you are walking straight into an operational nightmare.
So take a hard look at your own internal code bases. Are they operating predictably, or are they just waiting to break? Is your API integration a ticking time bomb, or is it a reliable operations layer? Thank you so much for joining me for this explainer, and I really hope these insights help you and your team build far more resilient systems.